Welcome to Bethel Online Education Hub. Learn anytime, anywhere. Don't forget to like, comment, share, and subscribe for more. Let's learn together, the Bethel way. Hello everyone. Welcome to our lesson for today. Our topic is the layers of the earth. We'll be exploring what's beneath our feet. I'll be your guide as we take a journey to the very center of our planet. Now, have you ever wondered what lies beneath the ground we walk on every day? Beneath our feet is a fascinating world made up of different layers that form our planet Earth. From the solid crust we live on to the fiery, blazing core at the very center, each layer has its own unique features and plays an important role in keeping our planet active and alive. In this exploration, we'll journey deep underground to discover the four main layers of the Earth: the crust, mantle, outer core, and inner core, and learn how they work together to shape the world we know today. Let's start with the outermost layer, the crust. The crust is like the skin of an apple. It's the thin, solid surface where we live, walk, build houses, grow plants, and where oceans rest. But even though it might feel deep when we dig a hole, the crust is actually very thin compared to the other layers, like a thin peel on a large fruit. There are two types of crust: the continental crust. This is thicker and made mostly of granite, found beneath land areas, and the oceanic crust, thinner and made mostly of basalt, a dense volcanic rock, found beneath the oceans. Together, with the uppermost part of the mantle, the crust forms the lithosphere, a rigid outer shell of the Earth. The asthenosphere is a region of the upper mantle that is solid but behaves plastically under stress, allowing the lithosphere to move on top of it. The lithosphere is the outermost rigid layer of the Earth, made up of the crust and the upper part of the mantle, while the asthenosphere is the ductile, semi-solid layer beneath it. The crust isn't one big piece. It's broken into huge sections called tectonic plates. These plates move slowly, sometimes crashing into each other or sliding apart, causing earthquakes, volcanoes, and even forming mountains. Even though it's the thinnest layer, the crust is very important. It's where all life exists. Mantle moeruvishik discontinuity, or MOHO, is the boundary between the Earth's crust and the mantle. It's a significant seismic discontinuity characterized by a sharp increase in seismic wave velocity, indicating a change in rock density and composition. The MOHO is named after the Croatian seismologist Andrija Mohorovičić, who first identified it in 1909. Next, beneath the crust is the mantle. And this is the thickest layer of the Earth. The mantle makes up about 84% of the Earth's total volume. It's made of hot, solid rock that moves very slowly, almost like thick melted candy. Even though it's solid, the intense heat and pressure inside the mantle cause the rocks to move in a process called convection, and this movement helps move the tectonic plates on the crust above. Now, the mantle has two parts: the upper mantle, found just below the crust. Part of it is called the asthenosphere, a soft, almost plastic-like layer where rocks are partially melted and can slowly flow. This is where those convection currents happen, moving the tectonic plates. The upper mantle and the crust together make up the lithosphere, which means rocky layer. The lower mantle, located beneath the upper mantle, stretching down to the outer core. It's made of solid rock too, but it's much hotter and under greater pressure. Even though it's solid because of this pressure, the rock still moves very slowly. If you could travel to the mantle, you'd find temperatures ranging from 500 degrees Celsius to over 4,000 C, hot enough to melt most metals. Now, let's travel deeper to the outer core. This is a layer of liquid metal, mostly iron and nickel. It's located beneath the lower mantle, and temperatures here can reach between 4,000 C to 6,000 C. What makes the outer core special is that the movement of these liquid metals creates Earth's magnetic field. This magnetic field is like an invisible shield that protects us from harmful radiation coming from space. The outer core is the only liquid layer inside the Earth. And finally, at the very center of the Earth is the inner core. This is a solid ball, made mostly of iron and nickel. And even though it's extremely hot, around 5,000 degrees Celsius to 7,000 C, as hot as the surface of the sun, it remains solid because of the immense pressure from the layers above, squeezing it tightly together. It's like a hot, solid metal ball at the heart of our planet. Scientists believe the inner core is slowly growing over time as the outer core cools and solidifies around its edges. Let's quickly review everything we've learned. Crust is a solid state. Its composition are rocks, granite, basalt, and its special feature is lithosphere. Upper mantle is a solid semi-molten. its composition are silicate rocks, and its special feature is asthenosphere flowing layer. Lower, Mantle is a solid, its composition are dense silicate rocks, and its special feature is thickest layer. Outer core is a liquid, its composition are iron and nickel, and its special feature is creates magnetic field. Inner core is a solid, its composition are iron and nickel, and its special feature is hottest layer. And that's our quick journey to the center of the Earth, from the crust we live on to the blazing hot core deep inside. Every layer plays a special role in Earth's structure, movements, and protection. Thank you for joining me today, and remember, there's a whole world of wonders right beneath our feet. Keep exploring and stay curious.